Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to talk about different types of real numbers. And by the end of this video, if you have a number, you would be able to list all the groups and sets that this number belongs to them, exactly like these examples. Let's go for the main chart that we have. Real numbers can be divided into two main groups, rational and irrational number. Rational number again can be divided into two groups, which are fractions and integers. There is a smaller group which will be located under the integers and we call it whole numbers. After that, we have natural numbers, which is a subgroup of whole numbers. Okay, what is the meaning of them? How can we realize if a number is integer, whole, rational number, irrational number, and so on? We don't worry, we are going to learn them one by one, and we are going to start with the smallest group, which is natural number. What is the meaning of natural number? First of all, natural number is going to start with 1, and if you see the pattern, you will realize the concept of that. And each time one unit will be added to the previous one. So the pattern is going to be like this: 1, 2, 3, 4, 5, 6. Pay attention. 0 is not included. Negative numbers are not included. This is the meaning of natural number. What about whole numbers? Exactly the set of natural numbers plus 0 will be whole number. So whole number is natural numbers in addition to 0. What does it mean, integers? It means in addition to having 0 and positive values, we have negative values as well. As you can see the pattern, it's really easy. But what is the meaning of fraction? Everything that contains a numerator and denominator, it's really easy. It can be positive or negative. For example, 3 over 2. We have a numerator and denominator. Minus 5 over 2, 1 over 8. But pay attention. There is a point here. For example, you may have 8 over 2. Is it a fraction? Yes, of course, it is written as a fraction form. But we can simplify that. For example, 8 over 2 will be 4. So it is better to consider that as a natural number, as a whole number, as an integer, right? We usually do not consider that as a fraction because every integer, every whole number, every natural number can be written as fraction. What is the meaning of rational numbers? Every number, any number that you can write in the form of a over b, where a and b are integer and b is not equal to 0. What does it mean? Pay attention to these examples. For example, we have 3 over 5, okay? If we wrote it in the fraction form, we have a fraction here, so we can assume that 3 is a and 5 is b, and as you can see, 5 is not 0. So it is a rational number. Look at the second one, minus 8 over 3. It is a rational number because we can write it as fraction. It is already a fraction, right? And b is not 0. What about 3? 3 is not a fraction. It is not in the form a over b. But we can write it as 3 over 1. So it's going to be a rational number. Or minus 7, which is an integer, right? It is not in the fraction form, but we can write it minus 7 over 1, and 1 is not equal to 0, so this is going to be a rational number. 0, or for example, we can write 0 as 0 over 1. Look, when we have a decimal, it can be a little bit tricky because it would be hard for you to understand. If you have a number in decimal form and it is terminating, it means it is going to stop somewhere. It's not going to continue, okay? Definitely, it's going to be a rational number. Or, in other case, the number is not terminating. It means it is not going to stop. But you can see a pattern. It's going to repeat. And for example, in this one, you can write it as 1.2 and the line above the 2. It means the 2 is going to repeat. When you have a repeating, it means definitely it's going to be a rational number. Or in this one, after 1.35, you can see a pattern, right? Which is 12. And you can write it as this. So it is a rational number. So I'm repeating again. When you have a decimal, a number in the decimal form, and it stops, it is terminating. It means it's not going to continue forever. Definitely it's going to be a rational number. Or when it is not terminating, it means it continues. But you can see a pattern, and the number is going, a pattern is going to repeat. Definitely you are going to have a rational number because we can convert them to fractions. This was what this was the point. Look at this one. What about this one? 3 over 0. I told you we cannot have a fraction which the denominator is 0. So this one is not defined. What about irrational number? As I told you, rational numbers are the numbers that we can write them as a over b, where b is not equal to 0. But irrational number is opposite of that. You cannot write them in the form of a over b, where a and b are integers and b is not equal to 0. Look at the first example. It is a number in decimal form. I told you to be a decimal to be a rational number first. It must stop somewhere, so it should not be continue. Or if it continues and if it is not terminating, you must see a pattern. Otherwise, it would be irrational. First of all, is it terminating? Is it going to stop somewhere? No, because I can see 3 dots at the end. Can you see a pattern? No, I cannot see any pattern. So it's going to be irrational number. I'm sorry, irrational number. Look at this next one. Is it terminating? No, because as you can see, we have 3 dots here and it's going to continue. Can you see any pattern? No. So it is going to be irrational number. What about pi? It is a really famous number, as you definitely know. It is 3.14 and it continues. Can we see any pattern? No. Is it terminating? No. So it is irrational number. Really important point about the root. You know the concept of radical, radicand, index, okay? When you have a root and the answer of that root is not an integer, for example, radical 9 is equal to 3. So the answer is integer, right? So it is rational number and it is integer. We have nothing to do with that. But when you have a root and the answer of that root is not an integer, it means you have irrational number. For example, look at this one, a square root of 10. It definitely is going to be 3 point something, but the answer is integer. No, it's not an integer. So it is irrational number. Or third root of 15. Is the answer integer? Definitely the answer is going to be 2 point something, right? But the answer is not an integer, so it's going to be irrational number. But when the answer is integer, it would be rational number. But pay attention here. For example, what would happen if you have a square root of minus 10? We know that under the root, when the index is even, must be positive, right? So it is not rational or it is not irrational. It is something else, which we call it imaginary number, and you are going to learn that later. Pay attention to this chart again. Probably, as you realize, when we have a look, we started from natural number. When we have a natural number, definitely it's going to be a whole number. When we have a whole number, it's going to be integers, right? So we can move backward. When we have a natural number, it is a whole number and it is an integer. And of course, it's going to be a rational number. And of course, it's going to be in the group of real numbers. Or for example, when we have a whole number, definitely it's going to be integer. Definitely it's going to be, definitely it's going to be rational number, and definitely it's going to be real number. So we can write all the sets, we can release all the sets. Or when we have a fraction, we can be sure that definitely it's going to be a rational number and real number as well. We are moving backward of the direction of the arrows. Okay, pay attention here. We want to classify the given numbers by listing all the number sets to which it belongs. We are going to start from the smallest group, 2. Is it a natural number? Yes, it is a natural number. So I'm going to write it natural number. I'm going to show it with n. When it is natural number, I'm going to move against the direction of the arrows. I can realize that definitely it's going to be a whole number. After that, definitely it's going to be an integer. After that, it's going to be a rational number. After that, it's going to be a real number. So these are all the sets that 2 belongs to them. What about negative 3? I told you always let's start with the smallest group. Is it a natural number? No, because it is negative. Is it a whole number? No, because it is negative. Is it integer? Yes, of course it is integer. So I can realize that this is going to be rational number and consequently it's going to be a real number, right? What about 0? I told you always start with the smallest group. Is it a natural number? No, of course it is not natural number because in natural number 0 is not included. Is it a whole number? Yes, it is a whole number. So I can realize that it is going to be integer. Definitely it is going to be rational number. Definitely it's going to be real number. What about 3 over 8? It is not a natural number, it is not a whole number, it is not an integer number, it's a fraction, right? So it is a fraction and definitely it's going to be a rational number and definitely it's going to be a real number. What about 8 over 4? This is exactly the point that I mentioned that, right? I know that you can see a fraction here, but as if you simplify that, you will realize that the answer would be 2. So we are going to continue with 2. Do not write fraction for this. Is it a natural number? Yes, of course. So it's going to be a whole number. Definitely it's going to be integer. Definitely it's going to be a rational number. Definitely it's going to be a real number. Look, here I have decimal. I told you decimal can be tricky. It can be tricky. When you have a decimal, to be rational, it must have one of these two conditions. First, it must repeat. You must see a pattern. Second, it must terminate, right? Look at this one. Is it terminating? No, because it continues forever. Can you see any pattern? Yes, I can see 12, 12, 12, 12. So I can write it as 0.1254, 12, and so on. So I can write it like this because 12 is going to repeat. When it is repeating, it means we have rational number. And after rational, of course, we are going to have real number. Look at the next one. Is it terminating? Yes, because it stops somewhere and you cannot see 3 dots at the end. So when it is terminating, definitely it's going to be a rational number and definitely it is real number. Look at next one. Is it terminating? No, because it continues forever. Can you see any pattern? No, I cannot see any pattern. So definitely it's going to be irrational number. And of course, when it is irrational, definitely it's going to be a real number. Third root of 20. Let's check. We have a radical, right? We have a root. So, is the answer integer? Do you know any number that if it is multiplies by itself 3 times, the answer would be 20? No, of course, I do not know any number like this. So the answer would not be integer. The answer can be something like 2 point something. 2 point something. So the answer is not integer. It means it is irrational number. And when it is irrational number, definitely it is going to be a real number. Look at next one. A square root of 16. Do you know any number that if it is multiply by itself, the answer would be 16. Yes, it is 4. The answer is a integer. So let's check the 4. Do not continue with radical 16 or square root of 16. We are going to continue with 4. Is it a natural number? Yes, of course it is a natural number. Definitely it's going to be a whole number. Therefore, it's going to be integer. Therefore, it's going to be rational number. Finally, it's going to be a real number. What about pi? As I told you, pi is 3.14 and it's not going to terminating and it's not going to you cannot see any pattern here. So definitely it's really famous example, irrational number, and definitely it is a real number because irrational numbers are a subset of real numbers. When something is irrational, definitely it's going to be a real number. Here you can find more examples and I strongly suggest you to solve them at home. Please write all the sets that these number belongs to them. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.